All right, good morning. Hopefully everybody's having a good Friday to start out. We'll be going over section 8.1b, adding and subtracting polynomials. So just as a reminder, you can only add and subtract like terms. To focus in a little bit more on what like terms are, those are things that have the same variable. I'm going to change that to be the same variable or variables and the same exponent on those variables. Right? So adding and subtracting polynomials is really just combining like terms. And you can set it up either vertically or horizontally. Okay, so for examples A and C, I'm going to show one vertically and one horizontally, and then I'll do the same thing for examples B and D. Okay, so if we take a look at example A, we're combining together a trinomial with a degree of 2 with another trinomial with a degree of 2. Since we're adding, there's nothing that we need to distribute. If we distributed the plus sign to all of these terms, they would stay the same. So when you're adding, you're really just going to rewrite or combine together the like terms. So I see 5x squared and 7x squared. We'll rewrite those together. Since I used an underline for those, for my first degree terms, I'm going to use a box. My first degree terms are 3x and negative 5x. All right, and last but not least, I'll use a little mini arrow. We have positive 2 and negative 7. Those both have a degree of 0. So setting it up horizontally, writing it like this way, what we're doing is we're putting together the terms of like degree next to each other. After that, we can combine these like terms. So 5x squared and 7x squared makes 12x squared. 3x minus 5x is negative 2x. And 2 minus 7 is negative 5, leaving us with our final answer of 12x squared minus 2x minus 5. All right, so another way to think about adding polynomials is to combine like terms vertically. So here we have 2x squared as the degree 2 term. We can rewrite that underneath 4x squared. And plus 3x and plus 1 likewise can all kind of move down if we're going to do this vertically. Right? Now again, since we're adding, there's nothing we need to do with each of these terms. They're going to stay the same. And we'll just combine like terms. So 7 plus 1 is 8. X plus 3x is 4x. And 4x squared plus 2x squared is 6x squared. Okay, so there's an example vertically and an example horizontally. All right, now what about when we're subtracting? Well, obviously things are a little different. We need to subtract not just the 4x, but we have to subtract all of these terms. So if you're doing it horizontally, what we're going to do is we're going to kind of distribute or change the sign on all of the terms in the second polynomial. So this would become negative 4x squared plus 5x and minus 6. All of the terms in the first polynomial don't have anything distributed to them, so they'll just stay as 2x squared plus x plus 12. And then from there we can combine like terms. So 2x squared and negative 4x squared, x and 5x, and 12 and negative 6. All right, so as our last step, combining like terms, our final answer we should end up with is negative 2x squared plus 6x plus 6. All right, so you can do the same thing vertically, right? And want to show, for example, if we're doing that with letter D, we notice at the beginning there's 3 terms and there's 4 terms, and then we'll ask ourselves, why is that? Well, you might notice the first expression here is missing an x. Okay, so I'm going to rewrite this one first so that I have a term of x, which would be 0x. Now, we're going to be subtracting this entire expression. So I'm going to be subtracting x to the third plus 5x squared plus 4x minus 7. So when we do each of these subtractions, we're going to start with our top term. So for example, 8, and then we're going to subtract the bottom term. So this would be, for example, 8 minus negative 7. Well, you might know 8 minus negative 7, well, that's plus 7, which is 15. Okay. Then we'll have 0x minus 4x, that's minus 4x. Negative x minus 5x is negative 6x squared, and 3x squared minus x squared, or 3x to the third minus x to the third is 2x to the third. All right, so showing our work vertically, right, we're going to be subtracting each of the terms as we move along. All right, so go ahead and try E, F, G, and H on your own. There is something a little bit different going on in E, so pause the video, try it on your own, and then see if you got it correct. Okay, hopefully you noticed what's different is we have to distribute not just the negative sign, but negative 2. So this would become negative 2x to the third and minus 24. And when we combine our like terms, we'll have x to the third plus 8x minus 24 as our final answer. The 8x and the minus 24 both don't have like terms. For f, we're going to be combining together like terms, and notice that there's a negative t to the squared and positive t squared. We have 9t and negative t, and plus 5. When two terms have the same coefficient and opposite signs, like t squared and negative t squared, they'll cancel out. So that just leaves behind 8t plus 5. For g, we have to distribute both the 6 to the p and the negative 8, and the negative sign to the p and the 2. After that, we're going to combine together all of our like terms. So 3p and 6p and negative p. And 1 minus 48 minus 2. It's important to keep the signs in front and to show your work reorganizing with like terms. So 3 plus 6 is 9p, minus p is 8p. 1 minus 48 is negative 47, minus 2 is negative 49. So 8p minus 49 should be our final answer for G. All right, and last but not least, hopefully you have already completed this and have already, if not, of course, pause the video. So negative 12 gets distributed to both terms, and we'll end up with 12x to the fourth minus 48x. After that, we can combine together like terms. 3x to the fourth and negative 38x. All right, we're next going to talk about two examples in real world. So we'll read the question together. I'll ask you guys then to pause the video, try it for a couple minutes on your own, and then take a look at the work. So the fence around a quadrilateral shaped pasture on Jose's farm is 3a to the squared plus 15a plus 9 long. Three sides of the fence, well, let's just draw a quick picture of this. All right, so three sides of the fence have lengths of 5a, 10a minus 2, and a squared minus 7. What's the length of the fourth side? And it doesn't have to be a rectangle. I was just drawing something with four sides here. Okay, well, first off, we know the whole thing, all of it together, is 3a squared plus 15a plus 9. So if that's the total perimeter, well, we know that to find this last side here, well, we're just going to have to take away each of the things that are already included in this perimeter. So we'll subtract 5a, we'll subtract a squared minus 7, and we'll subtract 10a minus 2. Another way you might have thought about this was to combine all these together first. And if you did it that way, that works as well. Okay, so either way, you can combine them together and then subtract it, or subtract each term one at a time. So 3a squared plus 15a plus 9 minus 5a minus a squared plus 7 minus 10a plus 2. Combining like terms, 3a squared minus a squared gives us 2a squared. 15a minus 5a minus 10a cancels out. And then finally, we'll have 9 plus 7 plus 2 is 18. So 2a squared plus 18. To quickly check our work, let's combine this together with our other three terms. So that 2a squared and a squared gets us to 3a squared. We have 5a and 10a, that gets us to 15a. And then negative 7 and negative 2 is negative 9. Negative 9 plus 18. Look at that. That ends up with our original expression. All right. A small town wants to compare the number of students enrolled in public and private schools. The polynomials below show the enrollment for each. So the public school has an enrollment of negative 19c squared plus 980c plus 48,989. And the private school has an enrollment of 40c plus 4,046. Write in a polynomial for how many more students are enrolled in public school than in private school. How many more in public than private school? If you're ever confused on how to set something like this up, kind of make up numbers and ask yourself how you would figure it out. So let's say a public school had 100 and the private school had 40. To figure out how many more, we would do the public minus the private. So what we're going to do with these expressions is we're going to do the public school amount minus the private school amount. That'll tell us how many more are enrolled in public school. From there, we can distribute our negative sign. And combine like terms. So our final answer should be negative 19c squared plus 940c plus, time to do a little calculator action. I don't need to use a calculator. And thank you guys for your patience. All right. So feel free to correct me if I was wrong. I'll do some push-ups on Monday. All right, last but not least, researchers studied the number of overnight stays in the U.S. National Park Service campgrounds. If you've never been there, wow, you should go. And in the backcountry, and if you've never been there, well, when you get older, you should go there. That's like where you go camping without a campsite in the middle of the woods. Over a 5-year period, researcher modeled the results in thousands with the following polynomials. So campgrounds had this amount, and the backcountry had this amount. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry? When I see both campgrounds and backcountry, I'm thinking to myself, we're going to need to add these together. And as we said before, adding is really just combining like terms. So we'll end up with 13.9x squared when we combine together negative 7.1 and 21. We'll end up with negative 320x when we combine together 180x and 140x. And I think it's 7,700 when we combine together 1,900 and 5,800. Okay, so that's our total amount of overnight stays for both the campgrounds and backcountry. Right, so I hopefully think you see that this lesson today isn't too crazy. It's just combining like terms, which we should be familiar with. All right, but some things to keep in mind as you're doing this on every problem is we wrote our equations in standard form. Our expressions. Right, we went from the highest degree to the lowest degree. Right, even when the problems were presented to us out of order, for example, like in this one here, right, we took the time to rewrite it and get to our final answer in standard form. All right, so you can use the rest of the class period to jump on in and start working on your homework for the weekend. All right, and if you have any questions, send Mr. Bowman an email. Send me an email. Have a nice day, guys.